Upper and lower bounds can play an important part in any part of maths, geometry, algebra, numbers. So let's have a look at what these actually are. Well, if we took the number 5 on a number line and we've actually rounded a number to get that 5, it could be a number that is above 5 and then we've rounded down, or it could be a number that is lower than 5 that we've rounded up. So if we said that the number is 5 to the nearest unit, that means that we've rounded it up in the tenths column to the nearest unit. If we say that it's to the nearest 10, it means that we've rounded it up from in the units column to get to the nearest 10. If we said that it's to the nearest tenth, then we've rounded it from the hundredths column, and so on. And this plays an important part in a lot of practical jobs. For instance, timber yards often sell wood, or DIY shops sell tiles at with an upper or lower bounds, to the nearest inch, for instance. And that has to be taken into account when building something. So the lower bound on the number 5 could be 4.5. So although we're being told that the value is 5, if we're told that it's to the nearest unit, the lower bound could be 4.5. It could be anything as low as 4.5. So if I had to buy the wood for construction, and I was told that each is 50 centimeters long to the nearest 10 centimeters, I couldn't just buy one if I needed 50 centimeters of it, because it could be 45 centimeters long. Now, in rounding, we've learnt that the number previously, if it's 4 or below, we round down. So when rounding, we can say the highest value it could be is 5.4. But here's the little confusing thing that we use with upper and lower bounds. Technically here, we could round down from 5.49 reoccurring. That means 5.4999999 and so on. We've done reoccurring numbers before. All of those, because it's 4 in the next column, would round down. And yet that is infinitely close to 5.5. If that 5.4 and the 9s went on forever, it's extremely close to 5.5. And hence, with upper and lower bounds, we simply say 5.5 rather than 5.4. I've actually seen exam questions where they have accepted 5.4 and 5.49 reoccurring, but it's best to put down 5.5 or whatever number you're working with. So to the nearest, if this was 5 centimeters and it's the nearest centimeter, then it could be 4.4 or 5. That would be the lower bound, anything from 4.5 to 5. And it could be as high as 5.5, the upper bound. Why this is important then is, for instance, if we've got a square here where the sides are 5 and we wanted to work out the area, we've had a look at the area and we know that we multiply the width by the length to get the area. Now that square, although we're saying it could be 5 times 5, which is 25, it actually, if we say it's to the nearest centimeter, it could be 5.5 times 5.5, which when you work it out is a much bigger shape, 30.25, as compared to 5 times 5. And if we looked at the minimum values, 4.5 times 4.5, the area is actually 20.25, a lot lower. So you can see there, if something has an upper and lower bound to the nearest centimeter, it can actually make quite a significant difference in, say, the area or volume or length that it covers. So 1 meter to the nearest centimeter, remember, is 1.005. It's a very important one to remember that. It's when we're talking about pounds. Most of the time, we're just mentioning, say, decimals. So, like I've said, 1 rounding to the nearest tenth is fairly easy because the tenths is the first decimal place. So you put 0.05 on, or you take 0.05 off. However, when we're referring to meters and we say the nearest centimetre, well, we know the centimetre column is the second decimal place because there's a centimetre is a hundredth of a metre. So when we're referring to the nearest centimetre, it has to be the third decimal place that adds the 5 on or takes it off. So the highest with the meter to the nearest centimetre would be 1.005, the lowest would be 0.995. And it's a similar thing with pounds and pennies. So always be careful which one you should be rounding up or rounding down to.